source greater than 0, and you shine light from one object to the other object, then there's going to be some sort of Doppler shift of the light. But in this situation, we just have light traveling along. It's deflected, and it undergoes some sort of change in velocity, or it undergoes an acceleration. I mean, I'm thinking off the top of my head that we shouldn't have to worry about Doppler shift with this. I don't think we have to worry about Doppler shift with this. In fact, yeah, I don't think we have to worry about Doppler shift, any sort of Doppler shifts with the light. If I'm wrong though, guys, by all means, find a source and like put it into the chat and be like, Matt, look at this, and I will definitely read over it. And then ask for your apology for my ignorance. but yeah, I don't think that we have to worry about Doppler shift for this. All right, so we need to go ahead and plug in. I believe I already copied the information. Let's see. I can get rid of this GM. That's already there. I can change this R to 1 because I already accounted for that. Let's see what we get. And it's unhappy about something I've copied and pasted. So let's see. All right. That's 1 over R squared, X squared, left, right. Integral 1 over. Oh, this, the last part of it all, should be dx. I think that might correct it. All right, perfect. And we must note, so when I believe when I initially did this problem, I only did the limits or the interval of my integration from 0 to some distance x, which I just assumed to be infinity. But that is slightly wrong, because if you're considering the total deflection by the light due to the sun, and again we're assuming a universe where it's just a photon in the sun, and you want to talk about the total deflection, you have to be able to include the entire flight path of the photon. And so with that in mind, we actually have to integrate from negative infinity to infinity with x. So that and this. I believe this ends up giving us what I want. Perfect. No, that's not the infinity sign. All right, give me a quick second. I'm going to quickly find the infinity sign on LaTeX. Some LaTeX document. Sorry for having to take a quick up. I think I'm missing a T and Y on that. So let's see if that fixes it. TY, TY. All right, there we go. Let's look at comments to make sure, like, if anyone's. So does anybody have any ideas? I think I don't think there's gonna be any sort of Doppler shift of the light, right? Because I mean, let's just imagine that now in our universe, we actually add the Earth in some distant source, and someone at the distant source pulses some light towards, not towards Earth, but towards a direction that's slightly off from Earth, I guess. The light's traveling. It kind of like touches the outskirts of the sun, and the sun bends the light now towards Earth. But during all that time, for the most part, the physical distance between the source of light and the Earth remains the same. Does the light undergo Doppler shift, even given, the deflection? And whenever I think about Doppler shift, I typically think about the fact that, and so I typically think that there's some sort of relative motion between the source of light and the target of where the light's going. But in this case, the distance hasn't changed. So I'm starting to think that, as far as Doppler shifts are concerned, the light will still be whatever its initial frequency was. And again, I could be very wrong, and if I am, guys, let me know. Hey, Black Hole Chaser, welcome to today's stream. And there's no relative gravitational potential between the source and the target. Okay, yeah. Thank you. That's a perfect idea to think about. Thank you, actually, for clarifying that. All right, so I'm running out of time, and I want to get through the problem, but we will definitely continue this, actually. Well, I'm glad that you're here. All right. So let's go ahead and do this integral. And again, guys, I'm not doing the integral here in front of you. We're going to rely on our internet sources to do this. So I'm going to go ahead and switch scenes. So let's actually find my OBS software. Let's see what scene one's doing for me. All right, scene one's not doing anything. So let me go ahead and make some quick corrections. Let's remove that. So you guys are kind of like seeing blackness right now. Let's duplicate. And let me be fast because I'm running out of time. Remove that as well so I don't end up switching to that one. All right, so we're going to go ahead and add a window for an internet browser. All right, so first things first, let's do this. I'll just use this one. It's already open, so it makes it easier on me. And so the objective is to do integral calculator. Whichever one pops up, that's the one we're going to use. Everyone else seems to like it, so it should work for what we're doing today. So the function we're working with is basically going to be 1 over, and this is going to be to the 3/2, to the 3/2 power. And basically, I think I could put r squared. I want to keep using those, but I should use these. Plus x squared. And I think that looks about right. And we're integrating from negative infinity to positive infinity. I think this is right. Let's quickly go back. 3/2 power. Let's make sure I've actually put 3/2. Yep. So let's go ahead and see what happens. What does it give us? And we're just going to look at the final solution. And if you guys want an explanation of the math, I'm more than happy to do so. All right, there's our final solution. So basically, we should get a ratio of 2 over r squared. So going back, oh wait, you guys can't really see that actually. Let me actually scroll down a little bit more. And so the solution's right here. Well, it's this ratio that's shown right here in the center of the screen. Kind of sort of in the center of the screen. That's because I have to adjust, but you guys can see. Sorry about that. And zoom in. There we go. So that's the solution, 2 over r squared. So going back to the initial scene, we're now going to end up getting, I didn't realize this was going to take this long. I had set up another problem too. Well, not set up. I actually just took a screenshot of another problem in my book because we were going to talk about equilibrium. But we can go ahead and just finish off this problem, and I might save that problem for my next stream or actually do some research for my next stream. And so our final solution will end up coming out to be, it's going to be GM, definitely over a C. There's going to be a factor of 2 in the numerator, and that R will cancel out with the R squared in such a way that we end up getting a factor of R in our denominator. And so now we can actually solve for what the deflection angle is due to as looking from it from the view of using Newtonian Newtonian gravitation. So let's see, no indent. So deflection angle. So what we end up getting now is, I'm sorry, give me one quick second. I'm going to scroll up top and just grab what I had before for it. Not that. Here, alpha, because alpha in our case is our deflection angle. So we can now plug in our delta V sub y, and we finally get that this is going to be equal to, and I can actually copy and paste my last fraction, and then just incorporate the fact that there's, or just add the fact that C should be squared. And there you have it. Our deflection angle alpha is equal to 2 times g times m over c squared times r. And if I'm not mistaken, this should be the exact same solution as what we were trying to solve for. 2gm c squared over r. Yep. I'm not gonna bother actually plugging in values to solve for this this value of 0.87 arc seconds, because that's pure arithmetic and probably a little bit of unit conversion. So we're not going to do that, but I'm going to get to some of the comments now, because I'm pretty sure I've missed some comments here. I'm going to assume, okay, so I'm reading through the comments, and Black Hole Chaser said something about a cosine hyperbolic. Might be referring to the integration that I was talking about. Photonic molecule. I'll take some time to definitely look it up afterwards. Okay. Thank you, Uncle Bill Druin. I understand what you're saying there. Like pressure or voltage. Doesn't matter much what happens between the two ends, only the levels at the ends. Or are you asking a question? Oh, are you talking about the general relativity solution for this? I'm not too sure. Yeah, the general relativity solution for this is twice as much, and of course, general relativity will take into consideration what happens to when you have things moving at the speed of light. In this case, we have photon, which does move at the speed of light. I would so black hole chaser. I would use AstroPi, but my ability to be able to use like Python is very limited. I need to. I probably should talk to Joe, and Joe can be able. So Joe's a fellow coworker who knows how. In fact, he's teaching courses on how to use Python. So I should probably talk to him. He could be able to help me out. So wait a second. So because I want to make sure before I like tell other people this that I might have conversations with about this. So my idea is that there will not be any sort of Doppler shifting, even considering the fact that you know that the photon essentially is gravitationally lensed. Is that the correct thing to say? Because that's my thought on this. Is that there will not be any sort of Doppler shifting due to gravitational lensing. Okay. Oh, that is so nice. See, personally, when I was in grad school and everyone was like, "You gotta learn Python. You gotta learn Python." Um, I think I signed up for like a course on Code Academy and started learning some stuff about Python, but I never really finished the course. But I've always been like a diehard, C++ person. But I mean, I keep hearing so many good things about Python and what you can do with it. So I probably should really start considering it. That's what I first started off with. Actually, I started off using IDL. It's getting better all the time. All right. Well, I'm definitely going to go ahead and talk to Joe and see what he can do to help me out and make me more Python literate. So Uncle Bill Druin states that he interpreted. I'm thinking about the statements that have been made by Uncle Bill Druin and both Larry. You know what? one of my streams, I probably could work through the math for it to see if there's going to be any sort of Doppler shifting, but I was just basically considering that there's this. That is an interesting thought, Larry. All right, guys, I've loved the conversation we've had today. It's now 1:03 p.m. and so you guys have probably given me some ideas as to what my next stream might be focused on, if it's not going to be research, that is. But yeah, guys, thank you for hanging out with me today and talking about today's topic. And it was great to have Black Hole Chaser here with us, talking about Python and about the problem today. Larry the G Cloud, Uncle Bill Druin, Peter, Susie, thank you guys for all a great conversation. In fact, just thank you everyone who came to view today's stream. So, but yeah, I'm gonna go ahead and now log off because it's lunchtime for me now. I'm pretty hungry, but I'm assuming you're talking about the calculus stuff, Larry. But yeah, I'm gonna go ahead and log off now. Thank you guys for stopping by. I'll be back on this Friday at 12 Central time. So if you have the time, come and check me out. Come out and have some fun talking about science. All right, guys. I'll talk to you guys later. Okay, bye.